Hi, my name is Philip, and this is the first video of a series on the fundamentals of MBSE. Before we dive into the modeling world, let's take a step back and have a look at systems engineering. Now, you might be thinking, why do we need systems engineering? Isn't this a course about MBSE? Well, yes, but MBSE is systems engineering. It is an evolution of the discipline. Hence, to understand MBSE, we must first understand systems engineering. And whatever your job is, you're part of the systems engineering process, somehow. So let's do a little refresh. We will stay at high altitude and focus on specific topics which resonates with MBSE, but we encourage you to take a dedicated systems engineering course. Going in depth of every step of the process will help you flatten the learning curve of MBSE. Ever wondered how engineers design something as complex as a combat aircraft or high-speed train? Where do they even start? How did they get all these pieces to work together? Well, systems engineering is the answer. It is an approach that we use to design and build complex systems that are too complex to be constructed all at once. But here's the thing, systems engineering isn't just about solving problems, it's about avoiding problems in the first place by being able to catch mistakes early, communicate effectively with every person involved, and get to a solution faster. Systems engineering is about finding a solution to a problem in an efficient way. For example, how do we go from we need a mode of transportation that provides efficient, comfortable, and environmentally sustainable travel for people over varying distances, to an actual passenger train? Well, systems engineering is the process that makes the idea into reality. A fundamental aspect of systems engineering is its focus on understanding a problem in its entirety. It's not enough to just manage the inner workings of the system. We must understand how everything interacts, both internally and externally, because a change in one subsystem can send ripples throughout the entire system. For example, inside the train, we have critical components like the engine, signal systems, and passenger management systems. But if we focus only on these, we miss a big part of the picture. The external interactions are just as important. For instance, the train relies on the power grid to receive electricity, and its speed is regulated by trackside signals. The train doesn't operate in isolation, it's part of a larger transportation network. Similarly, the station needs to coordinate with the train schedule to ensure passengers board and alight at the right time. And don't forget the passengers themselves, who influence the system with their behaviors, boarding at different times, needing specific accommodations, or experiencing delays. But systems engineering isn't a one-person job, it's a team effort. And when we say team, we mean a big team. First, we have the stakeholders. These are the people who define the high-level objectives of the project. They're thinking about the bigger picture, like what problem are we solving? Then we have project managers who are balancing schedules, risks, and budgets. They ensure the project stays on track. And then there are the engineering specialists, software engineers, mechanical engineers, electrical engineers, the experts who design the system's components. Systems engineering ties it all together. It ensures that the needs of all these participants, which are often contradicting each other, are met and keeps the project moving forward without confusion. Now here's the thing, a lot of companies tend to dive straight into the solution without fully understanding what they're building. They'll start with a broad idea but skip over the crucial steps of defining detailed requirements. This approach often leads to higher risks, errors, and consequently, cost overruns and delays. But with systems engineering, we flip that process on its head. Instead of jumping into the tech right away, we focus on understanding the problem first. It's about setting the stage properly so we don't just throw solutions at a vague problem. The numbers we show are exaggerated on purpose to make a point. So here's a graph that comes from a study evaluating the impact of systems engineering on projects. It shows how much was invested in systems engineering versus the average cost overrun of a project. As we see, projects that did not apply systems engineering saw a lot of cost overrun, while projects that invested managed to keep the budget in check. Systems engineering effort has a significant contribution to project performance.